So the agenda for today is a quick introduction into eco-design, what we do, and some of the challenges that we face in industry. Then I want to go on to macro technology overview and start off with what is a macro. Just a little bit of an understanding of that. What's the difference between a schematic project and a macro project, and the different types of macros. For example, a page macro, a window macro, and how to insert a placeholder object into a macro. And I'll discuss value sets, how to use them, what's the purpose of them, and variables. Then I'm going to jump into a live demo where I'm going to show you how we can use macros to efficiently create schematic drawings. And we're going to start by inserting a few page macros. Then I'm going to jump onto some window macros, and we're going to assign value sets to that as well. And the next phase of it is how we can use macros to efficiently create our schematic drawings using the Eco Schematic Generator, the ESG. So there's three methods that I'm going to discuss. The first one is how to insert macros using the embedded form method. The second one is using the Excel method. And the third one is actually just a live demo on how we can fully automate this entire process, where we take information from your PNIDs or device layout, extract that, import that into the ESG, and auto-generate the drawings completely. So that'll be quite an interesting and an exciting demo to watch and look forward to. And we'll go through some benefits and of macros and design automation as the conclusion. And we'll have a Q&A session at the end. So yeah, please stay by, and if you guys got any questions, make a note of it, and we'll discuss it at the end of the presentation. So okay, there's quite a lot to cover, and without further ado, I'll get started. So just a very quick introduction into eco design, what we do. Most of you guys are familiar with us. We are the official distributors for Eplan in New Zealand, and we have been the distributors since 2012, so roughly 13 years now. So some of the services that we provide are Eplan pre-sale services. We've also done proof of concepts where clients come to us and they want to understand whether Eplan is going to be suitable for their company, for their projects, and so forth. So we create like proof of concept drawings and designs, demo it to them, and in most cases it's suitable, and they end up purchasing Eplan. So once they purchase Eplan, we offer them onboard support. Generally, that's made up of about 4 hours of free support. Get your Eplan installed, a little bit of very basic. We don't call it training, but support how to use Eplan, and then we leave it up to you. And then we'll arrange a training, generally a 4 or 5 day training course to cover P8 or Pro Panel, depending on what you have. And then, of course, after that, we offer you technical support. And we also offer the services where we can create APIs and workflow solutions for you. So that's a brief overview of what we do. So we have 3 Eplan certified engineers in our company, and I'm one of them. Craig Walker and Philip Jovanovic is the other 2 certified Eplan certified engineers. So in our own right, we are electrical and control design engineers, and we use Eplan P8, Pro Panel, 3D on a regular basis, and we also use our own Eco Schematic Generator and our Eco tools as well. So our core focus is creating efficient design solutions, and we've got a lot of experience in this. So please reach out after this presentation if you want to get more efficiencies, and if you want us to help you with this and share some of our experiences with you. I mean, that's the whole idea, is to share our knowledge with you so that you can get the most efficiency out of your Eplan. And the way we do this is by automating the design process, and we'll cover that in a little bit of depth during the next 1 hour or so. And one of the things that we specialize in, as mentioned, is creating bespoke solutions to help our clients automate and optimize their workflow and create solutions for them. So these are slightly bespoke solutions. Yes, the fundamentals remain the same, but every client is slightly different, and we sit with you, understand your requirements, and we come up with a solution that works for you, where you can take information from your design sheet or workbook, whatever you call it, and use that same data to create macros and write the data into the macros and generate the drawings. So we offer our services to quite a wide range of clients. That is our design services, mostly to OEMs, people that manufacture plant and machinery. We do quite a bit of work in the dairy industry, baggage handling systems, material handling systems, switchboard manufacturers, water and wastewater. And we also got quite a few system integrators that we do designs for, and many more. We have completed over 1,000 Eplan projects, so we are vastly experienced in this area. So yeah, please reach out if you need any help. Challenges that we face today, and how is engineering done? So some of the challenges that we face, and one of the major ones is the high engineering costs, and that's made up of labor costs, skills shortage. I mean, most of you know it's not easy to find an Eplan engineer out there, and if you do find them, they don't come cheap. They're pretty expensive, and also retaining those resources. You know, first of all, you got to train them, and once you train them, they become skilled. And how do you retain them? So that's a bit of a challenge. The highest cost of software. I mean, Eplan is not the cheapest software. We all recognize that, but clients want a good return on their investment. And how do we get the best use out of your software? And that's what we're going to discuss today. And of course, everyone wants to stay competitive and profitable. And how do you do that with soaring engineering, manufacturing, and labor costs? And while all of this is going on, you still got to maintain your design integrity and offer the best quality and the highest level of accuracy to your clients. That is almost non-negotiable. So there's lots of challenges. How do we overcome these? So one of the ways of doing this is by creating smarter engineering solutions, and that is creating efficient design solutions is something that we're going to talk about in the next 1 hour. But also importantly is creating efficient manufacturing solutions. And Eplan has got solutions for these, and we will talk about this in one of the upcoming sessions, how we can use ProPanel and Eplan together with the Retail Perforex machine and so forth, how we can gain efficiencies from on the manufacturing side, but that's a session for another day. Of course, it all starts off with having an efficient design software, and most of you would have Eplan P8 or Eplan ProPanel, and we can add on things like Eplan eBuild. We can also add on the ESG, the Eco Schematic Generator, to accelerate the design process and bring more efficiencies to your Eplan. And something that we're going to cover in depth today is standard and repeatable designs in the form of macro technology. How can we use macros to actually accelerate the design process? And more importantly as well is embracing new technology. There's lots of new technology out there, and one of it is artificial intelligence. It's been bandied around a lot recently, and we've been using artificial intelligence or a form of artificial intelligence for many years now, where we use code to actually manipulate the data and sort the data and use that information to write directly into macros and generate the drawings. And that's what we will discuss today, how we can use artificial intelligence to automate your design process. Okay, so we'll get stuck into it. What is a macro? So most of you would have heard of an Eplan macro. So what is an Eplan macro? It's basically any typical drawing, any typical diagram can be created into a macro. And this could be as simple as a symbol. You can take a symbol and create it into a macro. You can take a black box. So for example, you may have created a VSD using a black box. You can then create a macro out of that, save that macro, and then insert this into your parts database so that when you insert the device, the macro accompanies that device. So that can be a macro as well. You can make an entire circuit into a macro. Basically anything that's repeatable. Just ask yourself, am I going to reuse the circuit down the track? And if the answer is yes, that should be created into a macro. And the best place to actually create a macro is in a macro project. Now, yes, you can create a macro from a schematic project. I don't recommend that, because at a later point when you try to fix that macro or try to edit it, you wouldn't know where that macro is because you may have, done 4, 5, 10 projects by that time. So the best place to create a macro is in a macro project. So what's the difference between a schematic project and a macro project? So a schematic project is your working project. So this is what you're going to send to the client. This is where you're going to create your schematics, your schedules, reports, bill of materials, all of that stuff. And you're going to create your panel layouts, your manufacturing information also in this schematic project. And eventually you're going to PDF this, you're going to print it, or maybe even send the native file to your client. You cannot insert a macro box into a schematic project. I'll talk about macro boxes shortly. So how about a macro project? So what is a macro project? Effectively, it's a project that's going to stay in-house. It's think of it as your library for all your macros. So ideally, you should have only one macro project, and there should be a manager looking after this macro project. I've seen companies with more than one macro project. It gets a bit difficult. It gets a bit hard to manage. So my suggestion, if possible, just to have one macro project and one manager looking after this project. And this is where you can create your macros, you can edit your macros, and you can manage your macros. And you can also insert a macro box to help you to manage those macros in the case of a window macro. And after that, you can generate this macro. So it does not mean that if you don't have access to this macro project, you don't have access to the macros. Once the macros are generated, they can reside on your server or in a location where it's accessible to other engineers and so forth. So you don't necessarily need to have access to the macro project itself. Okay, so I'll just run through some of the basic macros and how we can use them. Let's start with a page macro. So take the circuit here. It's a typical circuit. You've got your GPO, you may have a fan, you may have a light, and you may have this in every project. So why not create a page macro for this particular circuit here? And the next time you have a new project, all you do is you insert this page macro. A page macro could be as simple as a 400 volts bus. So you have a 400 volts bus, and then you can insert your starters thereafter. It could be DOL starters, VSDs, and so forth. So you don't have to redraw this 400 volts bus all the time. Just create a page macro of it. So window macros. So window macros are slightly different from page macros. They are more individual circuits. So think of a starter, DOL starter, or a VSD. So ideally, you may want to create that as a window because you may have more than one on a page. So just say, for example, you have 4 DOLs on a page. So it makes sense to create a window macro. So you can have a page macro with a 400 volts bus, and you can bring through your individual window macros. And you can have up to 26 variants of a macro, basically A to Z. It's the same macro name, and as you insert that, you press your tab key on your keyboard, you tab through the variants, find the variant that you want, and you can insert that. And I'll show you an example of how that works. And here's an example of our combination. We have combined a page macro and a window macro. So I've brought in a 400 volts bus, and I've brought in the individual window macros, and I basically made a circuit out of it. So placeholder object. So what is a placeholder object, and where would you use it, and what's the main reason for it? So take, for example, this DOL starter here. The circuit would remain the same whether it's a 0.75, 1.5, 2.2, 3 kilowatts, and so forth. So in the old days, we would create a circuit like this. We would copy and paste this 10 times, and then we would click into the individual components and change the circuit breaker or the overload for the protection, because of course the protection changes between a 0.75 and a 4 kilowatt or 5 kilowatt or 5.5 and so forth. So you cannot have the same components. So this is where the placeholder object comes in. Think of it as a recipe. So within the placeholder object, you can assign value sets in there. So for example, on a 0.75, you can choose a circuit breaker that's going to protect a 0.75. And so forth. For 1.5, 2.23, you can change the circuit breaker. And for example, the motor technical characteristics may change as well. So that can be also assigned to the placeholder. So when you change the kilowatt size from 0.75 to 1.5, the circuit breaker part number could change and the technical characteristics for the motor could change. So this makes your drawings a lot more efficient and a lot faster. All you do is you insert the macro, find the variant that you want, place it, and it's going to come up with a dialog box asking you what kilowatt size it is. If you select the kilowatt size, it's going to change the components for you. And again, I'll show you an example of how this works. So what about your tags? How do you change this? So the components within the circuit is fine. That's going to change in one of the placeholders. So to change the tags, you can add a second placeholder. And this placeholder handles the variables. So for example, your device tag or your motor description. So that can also become a variable. And later on, I'll show you exactly when we are automating the design process, how we change this information on the fly and write the data from an Excel sheet into these placeholders and generate the drawings. So these are all building blocks so that we can get to the end goal, which is automating the design. Okay, guys, so hopefully you can see my screen, my Eplan screen, and I've got a few different projects in here, but we'll focus on two of them for now, the first two. The first one is a schematic project, and the second one I've got here is a macro project. So how do you select between a schematic project and a macro project? So if I right-click onto this project property here, a project, I go into the properties, and in here, you'll see something called type of project. And this is where you select whether it's a schematic project or a macro project. There's only two options. So in this case, this is a schematic project. I'm going to leave it as that. And now that's set as a schematic project. The next one, in the second project in here, if I go to the properties, you notice that is selected as a macro project. So I'm happy with that. I'll leave that. And this is the project that we're going to generate our drawings into shortly. But for now, I'll just leave that aside and I'll jump onto my my macro project. So in here, I've got a lot of macros, demo macros, and so forth. And I'm happy to share some of these macros with you as a starting point if you want to know how to create these macros. So I've got a power distribution page in here. So this may be a typical page. Every project may start off like this. You might have a main circuit breaker and you might have some sort of power distribution. In this case, it's 3-phase, but you could have single phase as well. It doesn't really matter. But what if the main circuit breaker changes? How do I handle that? So that's where I insert a placeholder object, and you can insert a placeholder object into a page macro as well as a window macro. So if I right click, and if I go here, I can assign the value sets, or I can change the value set. So I can change this to say, for example, 100 amp. And now the components in there would change to 100 amps. I'll insert this shortly and I'll show you how that works. Here's my 230 volts utility circuit. Same thing. I'm going to use this quite regularly. So I created a page macro out of this. My 400 volts bus. I've created that into a page macro. And I've got a 24 volt power supply here with some sort of 24 volt distribution. And again, that is created into a page macro with a placeholder in here. So I'm just going to very quickly show you how to create a placeholder for those of you that don't know. So if you go to insert, this is Eplan 2025, it should be very similar to 2024 and 2023 as well. If you go to insert and you see macros under the navigator, if you click on that arrow going down, you can actually, you'll see there's an option here to insert a placeholder object. And if I click on that, you notice it's hanging onto my mouse and it wouldn't allow me to place it anywhere. I've got to select an object. So I'm going to select this black box, which is effectively the power supply. And I'm going to place it aside. So now you can see it's selected that black box into the placeholder. So I've got to ask myself, what do I want to change here? What do I want to change in this black box? And in this case, I want to change the part number. So that if I have a 5 amp power supply, the part number is going to be different to a 10 amp or a 20 amp power supply. So I'm just going to go new, and I'm going to find the part number. And if I just start typing part, it will come up with the part number here. And you'll notice that I've already got a part in there. That's because there's already a part in that black box, but doesn't matter. Let's go OK. And now I've got the option to select the variable. I'm just going to go apply. So there's two options in which I can create a variable. One, if I go to the values tab, and if I right click, or if I go plus sign here new, it'll create, oh, sorry. I can go here and create a new variable. And let's call this power supply part number. If I go OK, and again, if I go apply, that variable has been created, and now I can assign that variable. So if I go right click here, I can actually assign that variable here that I've just created. Or alternatively, I can go and write this. I can put a sharp bracket in there, PS part number, and close that, and it'll create that variable here for me. So there's two options in which you can create that. So how many value sets do I want to add? So I want to add, let's say, a 5 amp power supply. I can just call this 5 amps. I'll add 3 value sets, a 5 amp, 10 amp, and a 20 amp. And if I go new, I can create a new one in here, 10 amps, and new 20 amp. So I've got 3 different power supply sizes, and now because I've assigned that variable to a part number, the 3 dots appear, and that will take me straight into my parts database. And for the 5 amp, all I need to do is select a 5 amp power supply here, part number for the 5 amp power supply, go OK, and now I've got a 5 amp in there. The next one I'll select will be a 10 amp, OK, and the third one a 20 amp. And go OK. So very quickly, now I've created a placeholder with the value set in there. And if I go OK, and now I can see this placeholder. And if I right click in here, I can assign that value set. I'll change that to say to a 5 amp. And in here, that part has been changed. So that part has been changed to a 5 amp power supply. Just ignore this placeholder for now because that's was a previous one. And what if I want to add this circuit breaker to this power supply, to this placeholder? All I do is I select the circuit breaker, and I right click, and I assign object to the placeholder object. Do I want to deselect the other one? No, I don't want to deselect the other one. So now that circuit breaker has been added. So it's exactly the same deal. I can go new, part number, part number 1. I've already got a part number in there. And this time I can use this method here, and I can say circuit breaker part number, close, apply, and you notice it'll create that for me there. And same deal, I'll go in here, select a circuit breaker for a 5 amp power supply, and another circuit breaker for a 10 amp, and another circuit breaker for a 20 amp. I'm not going to go through that process. I'm going to cancel that. That's because I've already got a placeholder in here with those values already created for me. So I'm just going to delete this one here. And now if I change this back to, let's say, a 10 amp, it'll change the part number and it'll change the circuit breaker as well. And you can see it in the 20 amp, probably clearer. And that's now changed to a 6 amp circuit breaker, and the power supply has changed. So it's quite easy to insert a placeholder, and the same principle applies for any type of circuit like this. Okay, moving on. So yeah, I've got a few other macros, and these macros I haven't created from scratch. They've been downloaded from the data portal. So there's an example of let's say a Rockwell a CPU or interface module. I've got Siemens as well. So they're all available on the data portal in here. So these are mostly my Siemens macros, and I've got some Rockwell macros here as well. So they're all available on the data portal and can be easily downloaded. So anything can be created into a macro. So here I've got a contactor with a coil, and that's a macro with a placeholder to handle the different contactor sizes, because the coil is the main function in a contactor. Same as running feedback, I could have running feedback and I could have a macro for that. Here's a reversing starter, running feedback for that. I've got a DOL starter. So here's the DOL starter, and it's a window macro. And the difference here is I've got a macro box around this window macro, and the macro box allows me more or less the same functionality as a page macro to generate this macro. So if I double click onto this macro box, I've got the path where I want to generate this macro to, and I can also choose the variant. In this case, it's a variant A. And as I mentioned, there's up to 26 variants that you can select. So if I go OK, and I've got a reversing starter in here, same deal. It's exactly the same macro name, but it's a variant B. So when I insert this, I can use my tab key and I can tab through the variants. One thing I forgot to mention is on a page macro, because there's no macro box in here, how do you generate this macro? So you need to right click and go into the properties, and in here there's a path, this macro name, and this is where you can determine the path of this macro. Where do you want this macro to be generated? So in this case, it's generated into my local drive, Eco Design. This is my demo projects, demo P8, and this macro is here, power distribution. So same deal here with the VSD. I've got a VSD, it's got a macro box around it. And if I double click onto the macro box, this is the name for that macro. And if I click onto the folder, I can see where that macro has been generated. There's a macro here. And that's a variant A. Okay, guys, what I'm going to do now is I'm going to jump onto my schematic project, and I'm going to show you how we can use these macros in a schematic project. So once the macros are created, they've been generated. In this case, I'm on local drive, but it can be on the server, and it's available for everyone to use. So I'm going to go into my schematic project, and all I'm going to do is I'm going to right-click. If I right-click here, you'll see Insert Page Macros, and I'm going to insert a page macro from my list in here. And under my P8, I've got a few page macros in here. So the first one I'm going to insert is a power distribution page. And I can place that into page 10. And now it comes up with this dialog box asking me what size do I want my circuit breaker to be. So I'll choose 100 amps. And now if I click onto that page, I've got an 100 amp circuit breaker in here. And when I insert the other circuits, they will automatically cross-reference as long as the tags are the same. So the next thing I'll do is I'll insert a utilities page, a 230 volts utilities page, and I can insert that into page 12. That's fine. And here you can see that's a common circuit. So yeah, that's created into a page macro. The next one I'll insert is a power supply, the 24 volt power supply, the one that we just looked at, page 14. That's fine. And let's make that into a 10 amps. So it's just taken me a few seconds, and I've inserted 3 pages, 3 commonly used pages, which I've created into page macro. So that was fairly easy. The next thing I will do is I will insert some DOL starters into a page, and I'll insert some VSDs as well, just to show you how that works, window macros. So the first thing I'm going to do is I'm going to insert a blank page with a 400 volts bus. So I've got a page macro for that. I'm going to right click, and I'm going to insert a page macro with a 400 volts bus. And let's create that into page 15. Let's make it 20. We have a few spare pages, page 20, and my e-stop zone 1. Okay, so the next thing I'll do is I'm going to insert my DOL starters, and these are window macros. And if I press M on my keyboard, it takes me directly into my macros where they've been generated. So that's one method of doing it. The other method is to use your insert center. And if you click on your insert center, you will see the macros, window macros. And if I go into my demo, and here I do have a DOL starter, I can drag that and I can bring that into my circuit. So there's more than one way of doing that. And if I press X, Y on my keyboard, it places it in exactly the same position as where I created it. And if I press Enter, I can choose the value set. So here's a 0.75. I'm happy with that. The next one will be, I can choose a 1.5, then a 2.2, and then a 3 kilowatt. So in all of 10 or 20 seconds, I inserted a 400 volts bus and I inserted 4 starters from exactly the same macros using value sets. I was able to change the motor technical characteristics as well as the circuit breaker to match those motors. So when you're creating a macro, just be conscious of the number of circuits you want to place into a page. So for example, I know I want to place 4 DOL starters into this page. So try and get the macro box to size accordingly so that you can insert 4 DOL starters into a page so that the macro boxes don't overlap or something, and so it looks nice and tidy. And this helps when you're auto-generating the drawings as well. So a quick trick is what I do is to get that right. Let's go back into this DOL starter here. I duplicate this macro box. So I'll just go duplicate, pick a point, and I'll say 3, and I'll just have a quick check. Okay, right, that fits quite nicely. If it was too big, it'll overlap. If it's too small, it'll look a bit untidy. So I use the macro box as a quick way to determine the size, and of course you can use your measuring tool as well. And you can see, okay, in this case, 84 millimeters is a good size. So just be conscious of that. Okay, so jumping back into my macro project. But of course, after you insert the macro, you realize, oops, I made a mistake. This shouldn't be a 1.5. It should be a 2.2, no problem. If you right-click onto the placeholder, assign your value set, and you can change that to a 2.2. And the circuit breaker changes as well as the technical characteristics. So you're not stuck with it. You don't have to explode the block or anything like that, sort of recreate it. All you do is just change the value set. I'll insert another one and I'll show you how variants work as well. So I'm going to insert a new page macro, 400 volts bus. That's good. Let's insert that into page 20. Oops, because I got a page 20, so let me make that page 25. Page 25. And east of zone 2, that's fine. So exactly the same thing. I'm going to insert this DOL starter here. Press X, Y, and let's make this into a 3 kilowatt. Go OK. The next one, 4 kilowatt. And for the next one, I'm going to press my tab key. And when I press my tab key, I'm going to tab through the variants. So I've got a reversing starter as my variant B, and that's what I'm going to insert here. And I'll make that into a 5.5. So you can combine variants with value sets as well. So you have got a 5.5, a 4 kilowatt, and a 3 kilowatt. And of course, the circuit breakers have changed accordingly as well. So that's also possible. And if you completed the circuit, you can just use your T-nodes and close it off and delete that. So you don't have to explode the block. The drawings are completely editable even after creating macros. Okay, just for the fun of it, I'll insert one more. And this time I'll do a VST. And show you how that works. Page 30. And east of zone 3. And I'll insert a VST. I've got a VST here. And if I press X, Y on my keyboard, I'm going to insert that, a 4 kilowatt, that's fine. So in this case, I only can fit 3 VSTs in one page comfortably. So my macro box was sized accordingly or differently to fit 3 VSTs. So in this case, I've changed the circuit breaker, I've changed the VST part number, and I've changed my motor technical characteristics. Of course, you can add your cables to it, you can add your isolator, you can add anything to the placeholder. There's no restrictions on that. So I've got a 4 kilowatt, a 5.5, and a 7.5 with the circuit breaker and VSTs changed. Okay, guys, so that was a very quick introduction into how to insert macros manually after they've been created in your macro project. So what I'm going to do is I'm going to jump back into my presentation very quickly, and I'm going to show you the other methods of how we can use the ESG to automate this process. Using exactly the same macros, we are going to try to automate this design process. Instead of me manually inserting these macros and typing in all of these variables, we're going to automate that process. But I'll cover 3 scenarios with you. So the first method will be using our ESG, the embedded form method. So there's an embedded form in the ESG. You can insert your macros, you manually type in that information like your tags and so forth, and you then generate the schematic drawings. The second method that I want to show you, discuss, is the Excel method, where you insert the macros into Excel, which gives you a bit more flexibility. You can drag and drop down, and that makes it a little bit faster. And once that is done, you can generate the schematic drawings through the Excel method. And the third method, which I'm going to show you, which is more a demo, is how we can automate this process. We can take information from your PNIDs or from your device layout, extract that into Excel, import that into the ESG, and auto-populate using VBA code, auto-populate those variables, and literally press a button and generate these drawings. So I'll run you through the 3 different methods. So back to my macro project. And for this case, I'm going to use the Siemens macros, and pretty much the same macro. The big difference is here, now we've got a second placeholder. And that second placeholder is going to handle the variables, things like your device tag, your contactor DT, and your description. Okay, so there's 2 placeholders, one to handle the value sets, which is what we saw earlier on. That's not going to change, but I've inserted a second placeholder in here to handle the variables. This macro looks a little bit different. There's 2 types of brackets. So we've got the sharp brackets in here that handles the variables. So your device tags are variables. So when I write the device tag, it's going to write it into that, into the way it says device tag, into the bracket, and it's going to concatenate that with W1. And here, in the case of the isolator, it's going to concatenate that with the V, and the second cable W2, and the motor is going to concatenate M. So it makes the tags unique. Although I'm going to change the variable once, it's going to still make the tags unique. These open brackets here, the ESG handles it. So if I'm generating this into page 20, it's going to write 20Q for circuit breaker, and if it's a first circuit breaker, it'll be 20Q1. And same here for the terminals, it'll be 20X1, for example, if it's the first one. If it's the second one, it'll be 20X2, and so forth. The contactor here, that's a variable, and that's something that we're going to write. So there's 3 variables here, and the description is the 3rd variable which we're going to write. So we'll run through this, and that's a VSD. Pretty much the same deal here as well. Oh, sorry, this one here. That's pretty much the same deal as well. And we're going to generate these drawings here. Okay, so I'm just going to minimize this and jump back onto this project here. And I'm going to open up my ESG. Put this aside. ESG and the settings in here. So there's 3 critical settings in the ESG. One is where the directories reside, in other words, where my macros reside after I generate them. In this case, it's on my local drive, so I need to point to that folder. And the second one is which project am I generating into. So in this case, I'm going to generate into my P8 project. You can only select schematic projects here. So I'm going to generate into my P8 demo project. Because I'm using the embedded form method, I don't need to worry about the Excel sheet, but for the next method, I will select the Excel sheet. So that's done. I can close that. And now I'm going to bring through the embedded form. I'm going to open up the embedded form. And I'm going to select the macros that I want to generate. So in this case here, I'm going to use the Siemens macros. And I've got a page macro with a 400 volts bus, which is the first one I'm going to insert. And now I've inserted that macro. And where do I want to generate this? I want to generate this into my demo project. And MCC10. And I'll generate this into page 20. And what's my page description? Let's do a VSD starter, and stop zone 1. Okay, so the next, now that I've got my page macro, so I've got 4 hashtags here and an X, which means I want to generate my window macros along the X-axis. So I'm going to insert, in this case, let's do the VSD. So I've got a VSD in here, and I'll make that into a 4 kilowatt, and I'm going to insert that. So I've got a 4 kilowatt VSD in here. The next one I'll insert is a 5.5. And then a 7.5. So now I've inserted that. I can write the tags here. Just say, for example, TC101. And just to save time, I can copy that. And copy that, and I'll change that to 2, TC102 and TC103. And the description, I'll just call this General Transport 1, GT1, GT2, and GT3. Okay, so once I'm done, I'm happy with that. I've got all the information that I need in there. I can actually do one of two things. I can save this configuration. So if I'm not done with it, I want to take a lunch break or tea break or whatever it is, I can save this configuration. I come back, I can reload this configuration, and then I can, if I wanted to, I can generate this drawings. So let me generate this drawing here now. And I'll close that. And here's my MCC 10. And page 20, here's my VSDs generated with the tags written for me. So that took only a couple of seconds. Otherwise, I would have had to insert this manually. Yes, I can choose the value sets, but I would have needed to click on each of these devices and change the tags. So this saved a whole lot of time. Okay, so that's one method. I'll show you the Excel method. And to use the Excel method, I first of all need to open up a generic Excel sheet, which we supply, by the way, with the ESG. So give it a few seconds to open up. It's open up on another screen, so I'll just bring this across. And here I've got some information. I'm going to clear this page here. And the same deal here, I'm just going to just try and split my screen so it's easier for you to see. Same thing here. I'm going to insert this down here. I'm going to insert my macros, this time not into the embedded form, but into the Excel sheet. Same thing here. I'm just going to find my macros that I'm going to use, and I'm going to use exactly the same macros. My 400 volts bus. I'm going to insert that, and you notice that's inserted here, and it's brought up the variables. Exactly the same thing. It's just a different form. So my page description is, I'll just say VSD and e-stop zone 1. And now I'm going to insert my my VSD starters. Let's go with the 4 kilowatt, with the 5.5, and my 7.5. I'll maximize this. Now, being in Excel, it's a lot easier. So if I type in the tag, I can use the drag and drop method, and then that's going to change the tags pretty easy. GT1, GT3, and I want to just generate this into MCC 20 and into page 20 as well. Okay, so I've got all of that information handy, and now it's ready to be generated. I can either generate the current tab from here, or I can generate it from my ESG in Eplan P8. Okay, so before I do that, I just want to explain to you in the next presentation what I'm going to do, the fully automated solution. We're going to do exactly the same thing, but instead of us inserting the macros manually, we're going to write VBA code to write this path. That's all it's doing. It's writing the path where the macros are residing. And when I inserted this manually, this path came up, but doesn't stop me from using some sort of code to actually write this path and select the variable or the value set that I want and bring up these variables here. Instead of me typing this in here, I can use code to actually automate this process, or to use artificial intelligence to write this information for me. And that's going to save me a huge amount of time. So that's just in preparation for the next one. But this one here is a semi-automated one. So I'm just going to minimize that and jump back into my Eplan. Now I can close this, maximize my Eplan, and now I'm going to generate this drawing into MCC20. And now, because it's a current tab, I can generate this from the current tab into MCC20 and page 20, and it's exactly the same thing. It's just a different method, but exactly the same outcome. Very quickly, I was able to generate these schematic drawings. And this could be tens of drawings. It could be, hundreds of starters. It doesn't really matter. It's just a matter of calling these starters, changing the tags, and generating these drawings. Okay, guys. So now for the final presentation, and that's the auto-generated, the fully automated solution. And to do that, I'm going to change my project. And in this case, I'm going to generate that into my demo Pro Panel project. Okay, and I'm going to close this Excel sheet here and bring up a different Excel sheet. Okay, so I'm going to minimize this and I'm going to jump into another project, but using exactly the same macros. So this is my Pro Panel project, and there's lots of advantages of Pro Panel in terms of manufacturing and so forth. As I said, we'll cover that in one of the next sessions. So there's not much, there's not many drawings in here. There's a table of contents. And what I do have here is a device layout. So there's a couple of pages of device layout. And this is based on a real project that we've done some years ago, but it's a cut down version of it for demo purposes. And we actually ended up building the panel for this, and we got it in our workshop, or in our offices here. So here, this is based on a baggage handling system or conveyor system. And we've got we've imported this model, and we placed tags along the model. It's like a device layout of a PNID. So in here, I've got a black box with some critical information. So I've got my tag, the technical characteristic, the kilowatt size of this motor, what type of starter is it? Is it a DOL starter, or is it a VSD? Which e-stop zone it belongs to, and the description of that motor. So that's all it is. It's a whole lot of black boxes in here. And later on, we're going to extract that information into a temporary Excel sheet and load that into our ESG. So that continues onto this page here. Basically, it goes through the X-ray system. And these drives are mounted on the field. They are distributed drives. This is a Siemens system. So there's Profinet. The drives are on Profinet. And there's also IO-Link modules along the conveyor here as well, with some devices connected to them. So what I'm going to do is I'm going to select these two pages here, and using a standard Eplan function, which is a labeling function, I'm going to extract this information into a temporary sheet. Okay, so here's that, and I'll select these. Just I'll maximize that a little bit. So here you can see the raw data, the device tags, the description of the motors, what type of starter is it, or what type of device it is, and the technical characteristics, the kilowatt size, or is it an e-stop or photo Y or whatever, and where is it connected to? Is it connected to the MCC, or is it connected to a field module, and so forth. So this is my raw data, and we can do the same thing for you. You could have your raw data already in an Excel sheet, so you could avoid this step over here. So it doesn't necessarily mean that you have to go through this entire process. You can have parts of it already ready to go, and you can take that information from your current workbook or design sheet and load it straight into the auto generator. So I'm just going to minimize this for a minute and bring up my auto generator here, my ESG, and I've got another ESG here. So I'll give that a couple of seconds to open up, to start up. Okay, so here's my ESG, and in this case, I've got the data already loaded. So what I'm going to do is I'm going to do a reset, but I'm going to do a partial reset just to save some time, and I'm going to reset the master data. So I'm going to reset that. So the master data is now gone. That's been removed from here. So the first thing I'm going to do is I'm going to load this master data from this temporary Excel sheet. And that's the Excel sheet that it's looking at. And now it's going to load that. And of course, in your case, you might have your master data in a different sheet, and you can then load that into this auto generator here. So I've got the master data, and I'm going to just close that other sheet. I don't need that anymore. And the first thing I'm going to do is I'm going to create a schedule, an IO list, and a schedule of the devices that are mounted out in the field. So in here, I'll create schedule, and that's what I've done. Using VBA code, I've created an IO list. Now you may already have an IO list, so you can avoid the first two steps and go straight into from your IO list, take that information and use that in your generator. And this is my field devices. In here, all the drives that are mounted out in the field, and these are my IO link masters and which devices are connected to them. Then we break down the project into its different elements. For example, all the starters will be put onto one page. The PLC overview cards will be on another page, digital inputs, outputs, and so forth. And the reason we do that is it makes the project more manageable. So if there's a problem, we know where to go and look and find it. Or, for example, if something has changed, the starters have changed, you just need to clear this page, reinsert the macros, and then off you go, instead of trying to do the whole project in one sheet, which you can do, by the way, but it's just not advisable to do that. And we try and keep the same variables together, so it makes the code a lot easier as well. So I'm going to show you how this works. Here I've got my starters. I'm going to clear this page. And now I'm going to insert these macros and the variables. So what it's doing is looking at the schedule here, and I'm asking the question, which starters do I have and which type of starters? So it's going to bring through the correct macro, and I'm also going to manage it. So I'm going to pick up the variables, and then I'm going to auto-populate those variables. So the first thing I'm going to do is I'm going to insert macros. So now I've looked at my schedule and say, okay, I've got 8 DOL starters and I've got 3 VSDs. And at the same time, it's looking at the macro and saying, okay, which variables do I have? So I require device tag, the contactor tag, and the description, as well as I need to know the kilowatt size. So if I inserted these macros manually, which I can do as well, this is what I would have ended up with. But we're trying to automate that. So the next step would be to populate those variables. Yes, I can go and start typing them in one by one. It may take me 5 minutes to do that, but we're not going to do that. We're going to use code to populate those variables. So of course, I'm going through it manually now, but in reality, if I press this all button, it's going to insert the macros and it's going to populate the variables for me. And it'll go through tab by tab. So within a few minutes, I can auto-populate the sheet. So I'll just do a few tabs for you just to show you how it works. I'm going to clear that, insert the macros. So this is my PLC overview page. It's looking at the IO list and saying, okay, which modules am I using? And then I'm going to auto-populate the tags for it. I can go through all of them and do that. It's pretty much the same thing. I'm going to insert the macros and auto-populate the variables. Okay, import the variables. So I'm not going to go through all the tabs just to save time. And of course, I've got a whole lot of page macros here as well. And in my settings, in my settings, I can determine, the start page for my DOL starters, for my PLC, digital inputs, safety, and so forth in here. The IP addresses for my VSDs, the IP addresses for my devices out in the field, and which page macros I want. So I can add and remove page macros as well. I can choose my circuit breakers size, my power supply size. So these are some things that you can create in your settings as well. So I'm happy with all that information. I'm happy with everything in here. Now it's time for me to generate these schematic drawings. I can generate it from here as well. I've got the option, or I can generate it from my P8. So let me go back into my P8, and now I can go into my ESG, and this time I'm going to generate several tabs. So I'm going to select these tabs, bring them across, and if I wanted to, I can also generate my reports. If I click this button here, it's going to generate the reports at the same time. Let's leave that for now. We can manage that later, and I'm going to generate my drawings. So this whole process might take a minute or so to generate, but otherwise this would have been maybe a few weeks work to generate these drawings and to check them and so forth. So the whole idea is when you create your macros, you've got to test them, make sure that they work, test your VBA code, and if your macros are correct, your VBA code is correct, your outcome in most cases are going to be correct. So this is going to save you a whole lot of time checking your drawings as well. So while this is generating, just let you know, if you want us to help you with your macros, we can help you with your macros. We can help you with your VBA code. We can also offer training, so you can do it yourself. It's just up to you. So we offer the total solution. Yeah. So within a few minutes or a minute or so, it's basically generated these drawings for me. So here's my power distribution for my MCC. I'll just page through this power distribution to my field devices, my utilities page, power supply, Ethernet switch, HMI, my DOL starters, VSDs, my PLC overview rack. And again, I've downloaded these macros from the data portal. I didn't create any of these from scratch. Running feedback for my DOL starters, my IO, my photo-wise again, e-stops into my safety module. More contactors, calls for my contactors for my DOL starters. And back to my device layout. So if I page down, this is a Pro Panel project. So this is the panel layout in Pro Panel. This was created previously, but we've got technology now to auto-generate the panel layouts as well in 3D. And that is something we'll talk about in the subsequent webinars. So here's my this is my remote I/O devices out in the field, and there's some devices connected to those VSDs on Profinet. And this is a network overview. My I/O link modules and devices connected to them, control stations and beacon sound and so forth. E-stops. And that's basically the end of the project. So this was one small subsystem. Generally, a subsystem like this would be 80 to 100 pages. And one project that we had a few years ago had about 40 subsystems, about 4,000 of these conveyors. So without auto-generation, that project would have taken us maybe a couple of years to do. That was done in quite a record-breaking time by creating macros and being able to auto-generate that drawings. Okay, guys, so I'll just jump back into my presentation very quickly. So some of the key benefits of design automation, of course, there's a significant reduction in engineering costs. As you just saw, we were able to leverage artificial intelligence of sorts to auto-generate the schematic drawing, and that is significant savings, up to 70%. So it certainly pays for itself very quickly. Faster project turnaround. Quite often we get calls from clients where they say, you know what, we're under pressure, we need to get this job done. And the only way to do it is to auto-generate these drawings. And of course, that reduces the timeline quite significantly. Error-free deliverables. As I said, if the macros are done correctly, if your VBA code is done correctly, your outcome in most cases is correct. If there's something not right, you go back and you fix the macros or you fix the code. But generally, if it's tested, the outcome is generally quite accurate. Reusable elements. Of course, this is a modular design. The macros are completely reusable for future projects. They may need to be modified slightly, but once it's created, it only takes a couple of minutes to modify them, and they can be used over and over again to enhance your efficiency. Flexible and scalable. Of course, it is a long term. You can use this. It's completely scalable, whether you've got 1,000 conveyors in a project or it doesn't necessarily have to be conveyors. It could be anything for that matter. We use this in the dairy industry to for process valves and all sorts of things. We've done a project a few years ago for one of the dairy plants in the North Island here. That must have had in excess of 10,000 devices, and we auto-generated those drawings as well. So it can be adapted and flexible for any industry for that matter.